provided by eSpark Academy. As our notes will be in a simpler language rather than making it complex. Now, I will show you what is power, electric power. The electric power is nothing but product of voltage into current. Product of voltage into current. It is watt. Now you can see V square by R. Now given power can be I square into R. How all these are coming, how these expressions are being derived, I will tell you in nutshell. In physics already you have gone through the Ohm's law. Ohm's law is nothing but voltage is proportional to I when temperature is constant. That's why the graph comes out to be in this way. As you are applying voltage, the current will be increasing in this manner in Ohm's law. Now we will derive Ohm's law. Voltage is proportional to I. V is equal to R into I. The R is nothing but the constant. That's why we are taking here. And these values are substituted in this equation, and you will be getting this. Because I is substituted here as V is I equal to V by R. That we are substituting in those equations, and we will be getting V square by R. And in the same way we are substituting other things, and we will be getting I square R. Because V is equal to Ri, substitute in this equation, you will be getting in this equation, you will be getting I square R. As we are studying the electrical power, again one thing I have to explain you that the watt is nothing but V into I, but still you can elaborate it as joule per second. Further I will be explaining this to you. Now we will be going through the electrical energy actually. Now electrical energy is nothing but power into time. How much time the electrical power has been supplied, means power supplied for a respective time period. It is nothing but a electrical energy. Electrical energy will be power into time. You know power is Vi into T. Watt second. Joule is the unit of power. Now the electrical energy is nothing but expressed in watt hour kWh. It is nothing but a 1 kilowatt power being used for 1 hour. kWh is nothing but 1 kW power used for 1 hour. It is equivalent to 3.6 into 10 raised to 6 joules. 1 kWh. 1 kWh will be 3.6 into 10 raised to 6 joules. This is most important thing you have to know, because while dealing with electrical solutions, practical electrical solutions also, you will be helpful to calculate any kind of electrical numerical with the help of this 1 kWh is equal to 3.6 into 10 raised to 6 joules. Now even we can calculate it also, because I have just now shown you VIT. It is nothing but 1 kilowatt. 1 kilowatt means 1000 watts. 1000 watts. Now multiply it with 1 hour. 1 hour means 3600 seconds. And watt seconds is nothing but joules. Now you will get 6 into 10 raised to 5 joules, and as per expression 3.6 into 10 raised to 6 joules. In this way we have taken these shortcuts. As usual, many of them only will try to tell you that mug up these things, but I am not telling you to mug up anything. Only just go through the units which we are using here. This is watt hour, this is kilowatt hour. Kilowatt hour is nothing but 1000 watt means kilowatt, and hour you have to convert it into seconds. That's why 3600 seconds in 1 hour. When you multiply these all things, you will be getting 3.6 into 10 raised to 6 joules. Now I will be explaining you the elements, actually the resistance. What resistance is? Resistance, as from Ohm law already you know, V equal to Ri. In this, resistance will be calculated as V by I. Resistance is nothing but opposition to flow of current in electrical circuit. In electrical circuit, you can say as resistance is nothing but opposition to the flow of electrons or flow of current. It is expressed in Ohm. Now I will be explaining you the resistivity. Resistivity is nothing but a property of material. Resistivity is property of material to resist the flow of current. Now just I will clear this. Whenever you find it difficult to understand, or you find it to get with pace, always you try to pause the video and go in detail the steps, how I am calculating, how I am elaborating you. From that you will definitely understand the key facts which I am trying to understand, which I am trying to explain. Now I will be showing you resistivity. Resistivity is denoted by rho. R equal to rho L by A. Rho is the resistivity, L is the length in meters of any kind of wire it may be, and this is nothing but area of conductor. You can say area of conductor of wire. It is the length in meters of conductor. Resistivity is nothing but a property of material which tries to resist the flow of current. Now it will be shown how to calculate the unit of resistivity. From this expression you will let it come R into area divided by L will be rho. The R is nothing but ohm. The unit of R is ohm. Just now we have studied. Now area will be in meter square divided by length will be in meters. Just now I have told you. Now this will get cancelled and ohm meter will be the unit of resistivity. So simple it is. Just you should be hard and fast with the concepts, the basic concepts. Once you understand the basic concept of it, you will be able to calculate the units the same way as I am doing so. Now, we will be going through conductivity. Conductivity is just opposite to resistivity. Conductivity is nothing but sigma. It is denoted by sigma. It is 1 upon rho, means 1 upon resistivity. It is just the allowance of current. It is not the opposition. It will aid the current to flow through the element. Aid means help. It will help. Now you know resistivity unit is ohm per meter. Now opposite of this will be for conductivity. For conductivity you may derive as mho means reverse of ohm is mho per meter, or mho meter you can say. Mho per meter. Mho per meter will be mho per meter. Even in some way you can also say it as Siemens per meter also is the same unit, because Siemens is nothing but mho. 1 upon mho is nothing but Siemens. That's why you can also go through it. Now, effect of temperature on resistance. Actually, as we are dealing with metals, some or other way you will be dealing with non-metals, semiconductors. That's why it is very important that with the help of temperature, or you can say temperature is nothing but external parameter which will be affecting your circuit. That's why you should know which elements you are using practically and which elements have to be used, because in many way there are positive temperature coefficient and negative temperature coefficient. Each and every metal has been property of positive temperature coefficient. Positive temperature coefficient is nothing but positive temperature coefficient for metals. It will be nothing but temperature will be directly proportional to resistance, means it will vary as resistance varies, temperature will vary. Means resistance is increasing, temperature is increasing. In metals, all metals, there are some kind of metals which is having the property of metalloids, you can say, only except those. All metals will be having this property. Temperature will be directly proportional to resistance. It will vary in this way. That's why we are saying it as positive temperature coefficient. Now, for conductors, this will be suitable because conductors are nothing but the metals, you can say. Now, the one expression I will be showing you, one expression is that 1 plus alpha T. This is the actual expression which you will be using further as we go along to calculate the resistance for different temperature by taking the ambient temperature R0, and this is nothing but a alpha, it is a temperature coefficient, and this is nothing but a time, for which kind of time you will be dealing with, for what time, this period of time for which you will be calculating the resistance. Now you will be dealing with negative temperature coefficient. Negative temperature coefficient is NTC. This will be for semiconductors, which are semiconductors, silicon and germanium, you can see, silicon and germanium actually, which are being highly used in electronic devices on PCB mounted, means PCB circuits, you can say. Silicon and germanium in many electronic devices, they are even using this. This is nothing but temperature is inversely proportional to resistance. As the temperature increases, your resistance will decrease and vice versa. That's why we are calling them as negative temperature coefficient. Now insulator is nothing but a large resistance. It will provide a large resistance even if temperature increases. There is only a slight change in resistance. Insulators are nothing but they are not allowing current to flow through it. Semiconductors, what they actually do is they are partial conductors and partial insulators in between that. That's why these are semiconductors, and all metalloids are semiconductors. I will mention here the metalloids which are not metals, non-metals, metalloids. Now, what is the insulator? Diamond is an insulator or rubber is an insulator. As resistance increases, means even if the temperature increases, the resistance will be constant. Even if temperature is increasing. This is nothing but insulator. Irrespective of temperature, the resistance will remain constant. That's why we are saying it as insulator. Insulators are widely used in electrical circuits, even in big electrical tower lines, distribution lines, transmission lines. We are using these insulators in order to isolate the system, in order to isolate the conductors from each other while working. Now we will be dealing with type of resistors. What are the type of resistors? There are fixed resistor systems, there are variable resistor systems, there are some systems where resistor will be changing with respect to light, means you can say even through thermal power also the resistance is changing. By the help of light also resistance